Top 25 Mobile App Developer Interview Questions and Answers. Are you aspiring to land a dream job as a mobile app developer? In today's fast-paced tech world, mastering interviews is key to showcasing your skills in platforms like Android, iOS, and cross-platform frameworks. This guide features the top 25 interview questions, curated to cover essential concepts from architecture and performance to security and best practices. Whether you're a beginner or seasoned pro, these insights will sharpen your responses and boost your chances. Dive in and elevate your preparation. 1. What is the difference between an activity and a fragment in Android development? An activity in Android represents a single screen with a user interface, serving as the entry point for interacting with the app. It's managed by the system stack and handles lifecycle events like onCreate and onDestroy. Fragments, however, are modular components that can be embedded within an activity, allowing for reusable UI parts across different screens. They have their own lifecycle but depend on the host activities. Activities are ideal for full-screen experiences, while fragments enable flexible layouts, like in tablets where multiple fragments can coexist. This modularity improves code organization, supports dynamic UI changes, and enhances app scalability. For instance, a navigation drawer might use fragments for swappable content, reducing redundancy and improving maintainability in complex apps. Overall, fragments promote better separation of concerns. 2. Explain the MVC, MVP, and MVVM architectural patterns in mobile app development. MVC, Model View Controller, separates data, model, UI, view, and logic, controller, where the controller updates the view based on model changes, common in early iOS apps but can lead to bloated controllers. MVP, Model View Presenter, improves this by making the presenter handle logic and act as an intermediary, decoupling view from model for better testing, as seen in Android. MVVM, Model View ViewModel, uses data binding for automatic UI updates. The ViewModel exposes data and commands, surviving configuration changes via live data or observables. It's popular in Jetpack Compose or SwiftUI for reactive UIs. Each pattern enhances maintainability. MVC for simplicity, MVP for testability, MVVM for scalability in data-driven apps. Choosing depends on project needs, like MVVM for complex state management. 3. How does memory management work in iOS, and what is ARC? In iOS, memory management ensures efficient resource use to prevent leaks and crashes. Traditionally, it used manual reference counting, MRC, where developers manually retain, release objects. Automatic reference counting, ARC, introduced in iOS 5, automates this by inserting retain, release calls at compile time based on ownership rules. Objects are deallocated when their reference count hits 0. Strong references increase counts, while weak ones don't, avoiding retain cycles, common in delegate patterns. Developers use __weak or unowned in Swift to break cycles. ARC simplifies code but requires vigilance with closures and delegates. Tools like instruments help detect leaks. Overall, ARC boosts productivity, reduces errors, and optimizes performance in memory-constrained mobile environments, making apps more reliable and efficient. 4. What is auto layout in iOS, and how does it differ from springs and struts? Auto layout is iOS's constraint-based system for creating adaptive UIs that resize across devices and orientations. It defines relationships between views using constraints like width, height, alignment, and spacing, processed by the layout engine. This ensures views adapt dynamically without hardcoding frames. Springs and struts, the older method, use auto-resizing masks to define how views resize relative to superviews. Simple but limited for complex layouts, often leading to inconsistencies on varied screen sizes. Auto layout offers precision with priorities and intrinsic content sizes, supporting stacks and visual formats. It's essential for responsive designs in storyboards or code. While springs suit basic apps, auto layout excels in modern, multi-device development, reducing bugs and enhancing user experience. 5. What are the key differences between Flutter and React Native for cross-platform development? Flutter, from Google, uses Dart and compiles to native ARM code, offering a widget-based UI with hot reload for fast iterations. It renders its own UI via Skia engine, ensuring consistent look across platforms without native components, ideal for custom designs. React Native, by Facebook, leverages JavaScript and bridges to native UI elements, allowing code sharing while using platform-specific views for a native feel. Flutter's single codebase handles everything, reducing platform discrepancies, but React Native integrates easier with existing native codebases. Performance-wise, Flutter often edges out in animations due to direct rendering. Both support hot reload, but Flutter's ecosystem grows rapidly for web, desktop too. Choose Flutter for pixel-perfect UIs, React Native for JavaScript familiarity and native modules. 6. How do you handle background tasks in Android apps? Background tasks in Android ensure operations like downloads or syncing run without blocking the UI use work manager for deferred, guaranteed execution, supporting constraints like network availability. For immediate tasks, coroutines or Kotlin flows provide asynchronous handling. Services run in the background but need foreground notifications post-Oreo to avoid kills. Job scheduler or alarm manager schedule periodic tasks efficiently. Always respect battery optimizations with doze mode considerations. For long-running ops, foreground services with notifications keep them alive. Integrate Firebase Job Dispatcher for backward compatibility. Best practices include offloading to threads via a sync task, deprecated, or modern alternatives like RxJava. This maintains responsiveness, prevents ANRs, and complies with OS restrictions, enhancing user satisfaction and app reliability in real-world usage. 7. What is a RESTful API, and how do you consume it in a mobile app? A RESTful API uses HTTP methods, get, post, put, delete, for stateless communication over resources identified by URIs, returning JSON, XML. It follows principles like uniform interface and client-server separation for scalability. In mobile apps, consume via libraries. Retrofit, OKHTTP in Android for type-safe calls, or URL session. Alamofire in iOS parse responses with GSON, Moshi or Codable. Handle authentication via tokens in headers. Use async patterns like coroutines or async, await to avoid UI blocks. Error handling includes status codes, 200 OK, 404 not found, and retries for network issues. Caching with Realm optimizes offline use. Security involves HTTPS and input validation. This integration enables dynamic data fetching, powering features like user feeds, ensuring efficient, maintainable apps. 8. Explain push notifications and how to implement them in iOS. Push notifications alert users remotely via Apple's Push Notification Service, APNs. They enhance engagement with timely updates like messages or news. Implementation starts with registering for remote notifications in AppDelegate, requesting user permission. Generate device tokens and send to your server. Use Unisur Notification Center for local handling, defining categories for actions. For silent pushes, set content available. Handle in did receive remote notification. UI customization uses rich media attachments. Best practices include opt-in prompts, personalization, and frequency limits to avoid spam. Debugging via console or APN simulator. Integrate with Firebase for cross-platform ease. This feature boosts retention but requires careful management of battery privacy. Overall, push notifications transform passive apps into interactive experiences, driving user loyalty. 9. What are some best practices for mobile app security? Mobile app security protects against threats like data breaches. Use HTTPS for all network calls to encrypt data. Implement authentication with OAuth, JWT, avoiding hard-coded credentials. Store sensitive data in Keychain, iOS, or Keystore, Android, not shared preferences. Obfuscate code with ProGuard R8 to deter reverse engineering. Validate inputs to prevent SQL injection. XSS enable jailbreak, root detection to restrict access. Use biometric auth like Face ID. Regularly update dependencies to patch vulnerabilities. Conduct penetration testing and use tools like OWASP mobile security. Encrypt local databases with SQL cipher. Monitor for anomalies via analytics. Educate users on permissions. These practices comply with GDPR, CCPA, build trust, and safeguard user data in an era of rising cyber threats, ensuring long-term app success. 10. How can you optimize performance in a mobile app? Performance optimization ensures smooth, battery-efficient apps. Profile with tools like Android Profiler or instruments to identify bottlenecks. Minimize UI thread work using async operations like coroutines or GCD. Optimize images with compression, WebP formats. Use lazy loading for lists via Recycler View or UI Collection View. Reduce memory leaks with weak references and lifecycle-aware components. Cache data with core data for offline speed. Batch network requests and use pagination. Avoid overdraw in layouts, flatten hierarchies. Enable hardware acceleration. Test on low-end devices for real-world benchmarks. Monitor FPS with systrace. Update to latest SDKs for efficiencies. User feedback via crash reports refines further. These steps prevent lags, crashes, and poor reviews, delivering responsive experiences that retain users in competitive markets. 11. What is dependency injection, and why use it in mobile development? Dependency injection, DI, provides objects with their dependencies rather than creating them internally, promoting loose coupling. In mobile apps, frameworks like Dagger, Hilt, Android, or Swinject, iOS, automate this. It enhances testability by mocking dependencies in unit tests. Reduces boilerplate, as injectors handle instantiation. Supports modularity for large teams. For example, inject a repository into a view model instead of hardcoding. Types include constructor, setter, or field injection. Benefits: easier refactoring, scalable codebases, and adherence to solid principles. Without DI, code becomes tangled, hard to maintain. In cross-platform like Flutter, Provider, or Get, it serves similar roles. Overall, DI streamlines development, cuts bugs, and accelerates feature additions in evolving mobile ecosystems. 12. Explain the app lifecycle in Android. Android app lifecycle manages states from creation to destruction for resource efficiency. Activities follow. OnCreate for initialization, OnStart, when visible, OnResume for interaction. OnPause saves state on interruptions, OnStop when hidden, OnDestroy for cleanup. Fragments mirror this but tie to host activity. Services have OnCreate, OnStart command, OnDestroy. Handle configuration changes like rotations via OnSave instance state. Use ViewModel for data persistence across rotations. Broadcast receivers respond to system events. Best practices: avoid heavy ops in lifecycle methods, use lifecycle owner for observers. This ensures graceful handling of low memory kills, multitasking, and battery optimizations, preventing data loss and crashes for seamless user experiences. 13. What is SwiftUI, and how does it compare to UIKit? SwiftUI is Apple's declarative framework for building UIs across platforms, using code to describe what the UI should look like based on state. It auto-updates views via its state or at binding, simplifying reactivity. Previews enable live iterations. Compared to UIKit's imperative style, manually updating views via outlets, actions, SwiftUI reduces code, eliminates storyboards complexity. UIKit excels in custom controls and backward compatibility, iOS 9+, while SwiftUI requires iOS 13+. Combine integrates for data flows. Transitioning mixes both via UI hosting controller. Benefits: faster prototyping, type safety, and accessibility built-ins. For complex apps, UIKit's maturity aids, but SwiftUI's future-proofing drives adoption. It revolutionizes iOS development for intuitive, maintainable interfaces. 14. How do you handle offline functionality in mobile apps? Offline functionality ensures usability without internet via caching and syncing. Use local databases like Room, Android, or Core Data, iOS, to store data. Implement repositories that fetch from network or cache based on connectivity. Libraries like Work Manager schedule background syncs. Handle conflicts with last write wins or merging strategies. UI feedback like offline mode alerts users. Cache images with Glide, SD Web Image. For APIs, use retrofits caching interceptors. Test with airplane mode. Security: encrypt offline data. This boosts reliability in spotty networks like travel apps. Analytics track offline usage for improvements. Overall, it enhances user satisfaction, reduces abandonment, and differentiates apps in connectivity-challenged regions. 15. What are coroutines in Kotlin, and how do they simplify asynchronous programming? Coroutines are lightweight threads in Kotlin for concurrent code without blocking. They suspend, resume execution, making async ops readable like sequential code. Use suspend functions with launch, async builders in a coroutine scope. For example, fetch data in a view model scope without callbacks. Compared to RxJava's observables or Java threads complexity, coroutines reduce boilerplate, handle exceptions structured ly. Integrate with Flow for reactive streams. Dispatchers control contexts. Main for UI, I/O for network. Cancellation propagates cleanly. Benefits: efficient resource use, no callback hell, scalable for complex apps. In Android, they power Jetpack libraries. Mastering coroutines streamlines development, cuts bugs, and improves performance in multitasking mobile environments. 16. Explain unit testing in mobile development and tools used. Unit testing verifies individual code units in isolation for correctness. In mobile, it targets functions, classes without UI dependencies. Tools: Junit for Android Basics, extended by Mockito for mocking. Espresso, Roboelectric Test UI integrations. For iOS, XC Test with OC Mock. Kotlin uses Kotist. Write tests for edge cases, assertions on outputs. Benefits: early bug detection, refactoring confidence, documentation via tests. Follow TDD. Write tests first. Coverage tools like Jacoco measure completeness. CD integrates via Jenkins, GitHub Actions. Challenges: mocking external services. Overall, Robust testing ensures reliable apps, reduces regressions, and accelerates iterations in fast release cycles, fostering high-quality software. 17. What is app bundles in Android and their advantages? Android app bundles, AB, are publishing formats that let Google Play generate optimized APKs per device, including only needed resources like languages or densities. Unlike universal APKs, AABs reduce download sizes by 15 to 20%. Features: dynamic delivery for on-demand modules, shrinking unused code. Build with Android Studio, sign, and upload. Play Store handles splitting. Advantages: faster installs, lower storage use, better user retention. Supports instant apps for try before download. Backward compatible via tools. Developers focus on features, not variants. This optimizes distribution in diverse hardware ecosystems, cutting costs and improving global accessibility for apps. 18. How do you implement dark mode in iOS apps? Dark mode adapts UIs for low-light viewing, reducing eye strain. In iOS, detect via trait collection, user interface style. Use system colors like label color that auto-switch. For custom assets, provide light, dark variants in asset catalog. Override trait collection did change for dynamic updates. Semantic colors ensure consistency. Test with simulators toggling appearance. Benefits: accessibility, battery savings on OLED. Integrate with SwiftUI's environment values. For UIKit, update views in trait changes. Avoid hardcoding colors. Use UI color, dynamic provider smiley face. This enhances user experience, aligns with system preferences, and modernizes apps for broader appeal in varied usage scenarios. 19. What are the challenges of cross-platform development, and how to overcome them? Cross-platform development shares code but faces platform inconsistencies, performance overheads, and limited native access. Tools like Flutter mitigate with custom rendering, while React Native bridges natives. Challenges: UI discrepancies, solve via platform channels for native modules. Performance: optimize with ahead-of-time compilation. Testing: use emulators for both OS. Community plugins vary quality, vet carefully. Versioning mismatches require abstraction layers. Overcome by hybrid approaches. Core logic shared, UI native. Tools like Capacitor add WebTech flexibility. Benefits outweigh for faster launches, but plan for native fallbacks in complex features. This balances efficiency with quality in resource-constrained teams. 20. Explain accessibility features in mobile apps. Accessibility ensures apps are usable by all, including disabled users. Features: VoiceOver, iOS. TalkBack, Android, for screen reading, add labels, traits. Dynamic type for scalable text. Color contrast ratios above 4.5. 1. Gesture alternatives for motor impairments. Captions for media. Semantic markup like accessibility label. Test with simulators accessibility inspectors. Benefits: wider audience, legal compliance, ADA. Integrate early via design systems. Tools: Axe for audits. Challenges: balancing aesthetics with function. Overall, it fosters inclusivity, boosts ratings, and reflects ethical development in diverse user bases. 21. How do you manage state in React Native apps? State management in React Native handles data flow for reactive UIs. Use local state via useState for components. For global, Redux stores actions, reducers, with middleware like Thunk for async. Context API provides simpler sharing without props drilling. Mobex offers observable reactivity. For persistence, async storage or Realm. Best practices: normalize data, memoize selectors. Integrate hooks like useSelector. Challenges: overfetching, use caching. Tools: React DevTools for inspection. This ensures consistent, performant apps, reducing bugs in complex navigation flows. 22. What is Jetpack Compose, and its benefits over XML layouts? Jetpack Compose is Android's declarative UI toolkit using Kotlin for composable functions that describe UIs based on state. Unlike imperative XML with find view by ID, it auto-recomposes on changes. Benefits: less code, live previews, theming with Material U. Integrates animations easily. State hoisting promotes reusability. Backward compatible via interop with views. Challenges: learning curve for XML users. Overall, it accelerates development, cuts boilerplate, and enables dynamic, responsive designs for modern apps. 23. How do you debug mobile apps effectively? Debugging identifies and fixes issues efficiently. Use breakpoints in Android Studio, Xcode for step-through. Logcat, console for logs. Tools: Charles for network inspection. Crashlytics for real device crashes. Profilers track memory, CPU. Remote debugging via Chrome for web views. Reproduce bugs with emulators. Unit tests isolate problems. Version control bisects changes. User reports via shake gestures. Best practices. Modular code, error handling. This minimizes downtime, ensures stability in production. 24. Explain C/CD pipelines for mobile development. C/CD automates building, testing, deploying mobile apps. Tools. Jenkins, GitHub Actions, Fastlane. C builds on commits, runs tests. CD deploys to beta, test flight, play console, or production. Benefits. Faster releases, fewer errors. Integrate linting, signing. Challenges. Platform-specific configs. Use containers for consistency. This streamlines collaboration, supports agile iterations in competitive markets. 25. What trends are shaping mobile app development in 2025? In 2025, AI integration like on-device ML enhances personalization. 5G enables AR, VR experiences. Privacy focus drives secure data handling. Cross-platform tools evolve for web, desktop Unity. Sustainability optimizes for battery. Foldables demand adaptive UIs. Web3 features like NFTs emerge. Low-code platforms democratize development. These trends demand versatile skills, pushing innovation for engaging, efficient apps. As you wrap up your preparation with these top questions, remember that confidence comes from practice. Rehearse answers aloud, tailor them to your experiences, and stay updated on tech evolves. Interviews test not just knowledge but problem solving and passion. You've got the tools. Now shine. Good luck.